So the last example problem of this section is on restricting a function's domain. So example 6 is going to be pretty much the same thing as example 5, except when we get our original function graph, we have to look at the graph and decide which values on the graph are we going to use and which ones are we not. And then we're going to restrict our domain. Other than that though, same problem as last time. So, like we did before, we have our table. I'm going to use those same values we used before in our table to get the points to plot our original graph. So we have the points -2, -1, 0, 1, and 2. Yay! Alright, so all I'm going to do, I'm going to substitute in these values for x to get my y. So let's get going. So, on the first one, we're going to find f of -2. So I'm going to replace this x right here with the -2. So we'll have 2, there's the x, so it'll be -2 squared minus 18. Now be careful when you solve this part right here. If you think about order of operations, okay, you do the exponent before you multiply. So you do not do, beware, the demon cats will get you at this part. You do not do 2 times -2 then square. You gotta square the -2 first and then multiply by 2. Okay, so -2 squared is 4, and then 4 times 2 will give me 8. And then 8 minus 18 will give me a -10. So the first point I'm going to be plotting is at -2, -10. Alright, you're going to do the same thing with all the rest of the values. So my next value, f of -1. So I'm going to replace that x with the -1. So we have 2 parentheses -1 squared minus 18. Alright, remember we square first, don't multiply first. So -1 squared, -1 times -1 is 1, times 2 will give me a 2. And 2 minus 18 will give me a -16. So the next point I'm going to be plotting is at -1, -16. Alright, next point at 0. F of 0. Okay, so at f of 0, we're going to do 2 times 0 squared minus 18. Square the 0 first. 0 times 0 is 0. Times 2 will give me 0. And 0 minus 18 will give me a -18. So the next point I'm going to plot is at 0, -18. Okay, next point, we got 1 and 2 left. Our next point, f of 1. Okay, so we have 2 times 1 squared minus 18. 1 squared, 1 times 1 is 1, times 2 is a 2. And 2 minus 18 will give me -16. So the next point we'll be plotting is at 1, -16. And finally, the last point we'll be plotting, we're going to find f of 2. So we have 2 times 2 squared minus 18. 2 squared is 4, and 4 times 2 is 8. And 8 minus 10, 8 minus 18, 8 minus 18, that's an 18, will give me a -10. So the last point I'm going to be plotting is at 2, -10. Alright guys, let's get our original function graphed, and then we have to decide which part of the function are we going to leave on the graph and which part are we going to restrict to make sure that our inverse will be a function. Okay, so my first point's at -2, 10. So, -2, -10. So -2 down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So about right there. My next point is at -1, 16. So -1, -16. So 10, 11, 12, 13, 14, 15, 16. And my final point, or not my final point, my next point is at 0, -18. My next point is at 1, -16. And my last point is at 2, -10. So got this really skinny U graph going on right now. Okay, so if you notice, okay, our original function Okay, it is a function because it will pass the vertical line test. No matter where you draw vertical lines, it will pass. It only hits it once. Okay, but if you think about this thing rotating sideways, that's what's going to happen when you find the inverse. Currently, this is going to fail the vertical line test. Okay, so the inverse is currently not a function. Okay, and you can also tell from the original graph, it fails the horizontal line test. See? It fails, super fails. Hits it twice. So we know that the inverse will not be a function, but the inverse deserves to be a function. So we're going to force this function, we're going to restrict part of it so its inverse will in fact be a function. Okay, and then it'll be having a blast because it'll be a function. So when I'm looking at this function, if you remember from the Prezi video, okay, typically when we restrict the graph, we kind of pick like half the graph, and we typically pick the positive side. Okay, so I'm going to be picking the positive side of this graph. So this is the part of the graph that I'm going to be focusing on. So my inverse will be a function. Okay, technically you could use the other side of the graph as well. Okay, but again, mathematicians usually like to use positive things. Okay, so the only values on here, we're starting at the point 0 at -18 and using all of our positive values. So the only ones I'm going to focus on right now are these right here. These are the only values in my table that will allow the inverse to also be a function. So I'm going to kind of ignore these previous ones. I'm going to act like they don't exist. Okay, so I'm going to only graph these last 3 points on my graph down here, and that's the graph we're going to focus on when we find our domain and range. And that will give us a restricted domain. So I'm going to plot these 3 last points on my second graph. So my last 3 points are at 0, -18, 1, -16, and 2 at -10. 2, 3, 4, 5, 6, 7, 8, 9, 10. So we only kind of have half the graph. Just kind of like, just half the graph. Okay, and this one does pass the horizontal line test. So this graph right here will have an inverse that's a function. Yay! Okay, so when we find the domain and range, we're only going to focus on this graph right here. Kind of act like this graph doesn't exist and these first 2 points don't exist anymore. Ignore them for the rest of the problem. Alright, so let's talk about our domain and range. Again, for domain, it involves the x-axis. We ask ourselves how far left does it go first, which if you notice, our new graph, well, nothing's over here. The farthest left on the x we go is at 0. That's the furthest x value we see going to the left, and it can equal 0. So we're going to put a bracket on that bad boy. Ah. So our domain goes from 0, and then we ask ourselves how far right does it go? Okay, and even though it doesn't look like it, parabolas always get wider and wider. Okay, so since it keeps getting wider and wider, we're going to span all of the x's in this direction. It's going to keep getting wider and wider. So this one will head to positive infinity for forever with Buzz Lightyear. Holy hot dog. So this is the interval notation, inequality notation. Okay, remember domain involves x's, and we have a 0. Okay, and these are the values on the x-axis. These values over here are larger than 0, and we can equal 0. So it would be greater than or equal to 0. Alright, and then for the range, this is when you ask yourself, how low does the graph go? How high does it go? Because we're involving the y values. So let's see how low it goes. It's going down, 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 down. Bam! That's the lowest y value on our graph. Okay, so we're going all the way down to -18, and it can equal -18, so we're going to put a bracket on that bad boy. And then we ask ourselves, how high does the graph go? Okay, well that arrow means it keeps going up for forever, so to infinity and beyond with Buzz Lightyear. Okay, and then our range, okay, this is now y. Okay, and we have a -18 involved. And then you have to ask yourselves, are these values up here larger or smaller than -18? Well, the values up here are larger than -18. And we can equal -18. So we put greater than or equal to. So that is my current domain and range for the original graph. Okay, so this is the restricted graph. This is the only one we're going to focus on when we talk about the inverse. Alrighty, so shifting gears now. So first up, find the inverse equation. We're pros at this by now. So I'm going to start with the original equation, which is 2x squared minus 18. That was our original. Okay, and remember, it's easier if you go ahead and change the f of x to a y when we solve for the inverse equation. Alright guys, let's get going. So here, now, first step that we're going to do is interchange our x and our y value. So these two bad boys are going to flip-flop. Okay, so my y is going to transform into an x. And my x is going to transform into a y. So the 2 stays the same. My y replaces the x. We're going to have the squared minus 18. Alright, and then from here we just solve for y. Again, I like my y to be on the left-hand side, so I'm going to rewrite this with y on the left-hand side, but that's just a personal preference. Alright, who's pumped up? Let's solve this bad boy for y. So, first step, to get negative 18 to the other side. The first thing you do, the opposite of negative 18 is positive 18. Negative 18 plus 18 is 0. And then when I add it to the other side, x and 18 are not like terms, so I cannot add them. So my next phase of the equation would be 2y squared equals x plus 18. I'm going to bring it up here so I'm out of room. Alright, so now currently the 2 is getting in the way. So the way that we bring 2 to the other side, 2 is secretly multiplying to the y. So to move it over, we divide both sides by 2. And remember, you have to divide the entire side by 2. You don't get to pick and choose what you divide by. So my next equation will be the 2's cancel. So you're left with y squared equals x plus 18 all over 2. Alright, and then the last step to get y by itself, remember the way we undo a square, the inverse of a squared, the opposite, is a square root. So we got square root both sides, yay! And the square root will cancel out the square. So now we're left with y equals the square root of x plus 18 over 2. Now, you're probably thinking, hello, Miss Long, you just let the demon cats get to you. I don't see the plus or minus sitting there. Well, there's a reason why I did not put the plus or minus there. Okay, so since we restricted our domain up here and we're only focusing on the positive values, I'm not going to put the positive and negative side because then my inverse will have both sides graphed. Okay, if you kind of visualize, the inverse is going to look like this. Okay, the positive side of the graph is the one above the x-axis, and the negative side of the graph is the one below the x-axis. So if I have both sides, it will fail the vertical line test. So I'm only going to use the positive side, which if you see here, the positive side definitely passes the vertical line test. So, I know it's a little weird, but when you restrict the domain and you have a squared, this is the only time you don't use a plus or minus. Okay, every other time, use plus or minus. Okay, so just be careful, watch out for that. So I'm going to use my fancy notation. So the inverse will be just the positive version. So it'll be x plus 18, square root of that, all over 2. That's our lovely equation. Okay, so next step, just like we did before in example 4 and 5, to get our new set of values on our table, we use the previous ones. But since we restricted the domain, I'm only going to use these 3. Okay, I'm going to act like the first 2 don't exist. So on my table, I'm just going to act like these first 2 don't exist because we're not going to use them. So I'm going to scratch them out so I'm not even tempted to use them. Okay, when you make your table, you can just, you know, have 3 spots if you want. But since I made 5, I'm just going to scratch them out so I'm not even tempted to put them down. Okay, so my first point in the restricted domain that's allowed is at the point 0, negative 18. Okay, but when we interchange the x and y values, we'll get negative 18, 0. Okay, the next point, it was 1, negative 16, but now it's going to be negative 16, 1. Alright, and my final point I'll be graphing, my first point was, or my last point was 2, negative 10, but now it will change into negative 10, 2. Alright guys, let's get this graphed. So I have a point at negative 18, 0, which is right here. I have a point at negative 16, 1. And then I have a point at negative 10, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 2. Kind of like that. Alright, there's our inverse graph. Okay, and if you see here, if I were to draw on the line y equals x, let's see, I'll pick a pretty color, let's pick purple. Alright, so for the line y equals x, I'll just make a table over here. Okay, if you don't remember what those values are, I'll just show you again real quickly. So I'm just going to pick like negative 2, 0, and 2 on my x. So this is the equation where y equals x. So if x is negative 2, y is negative 2. If y is 0, x is 0. And if x is 2, y will be 2. So we got negative 2, 0, 0, and 2, 2. So let's see if our graph is symmetrical to that line. Let's see what happens. And again, if you have graph paper, it'll look a little better than mine. But we're pretty close, yeah. If I were to fold this on that line, I'm pretty sure that these two graphs would be on top of each other. So awesome. So this is the line y equals x. Alright guys, last phase of the problem, the domain or range. Now, I could sit here and just ask myself like we normally do, how far left, how far right, how low, how high. Okay, but remember the shortcut, since I already have my restricted domain or range, all I have to do is interchange the domain or range of my original graph. Bam! I'll have the domain or range of my inverse graph. So, the domain of my inverse will be the range of my original. So, my range was from negative 18 to infinity, so that will be my domain of the inverse graph. Which interval notation would be, since this one is y is greater than or negative 18, okay, the only thing that's going to change since it's domain, the y will be an x. So x will be greater than or equal to negative 18. So you can use either of those notations. Okay, and if you look at the graph, if you say how far left does it go, well look at that. It goes all the way up to negative 18. And if you ask yourself how far right does it go, well that graph keeps heading to the right for forever. So that totally works. Isn't that neat? Okay, so for the range, so the range of your inverse will be whatever the domain was in the original. So my domain went from 0 to positive infinity. So the range will go from 0 to positive infinity. Alright, and then the inequality notation, since it's x is greater than or equal to 0 here, now that x will turn into a y. So y is greater than or equal to 0. And again, if you look at the graph, it makes sense because the lowest point on the graph on the y is at 0, and then this graph will get higher and higher. So it goes to infinity. So awesome. Alright, so this is the end of the problem. I hope you had a blast. Okay, and now we'll be moving on to logarithms, so get excited.